synthetic glucosamine hydrochloride from waste shrimp shells. 1. Ingredient: chemicals. Dried shrimp shells are removed from the flesh. Hydrochloric acid solution. Sodium hydroxide, hydrogen peroxide, ethanol, activated carbon, filter paper, universal indicator paper, and purple litmus. Lab instrument: conical flask, roughneck flask, analytical balance, thermometer, hair dryer, reflux, condenser, filter, glass rod, rubber stopper. 2. Experimental steps. A. Synthesis of chitin from shrimp shells. Step 1. Weigh 30 grams of dried shrimp shells into a 1 liter beaker. Then slowly add 150 milliliters of 10% hydrochloric acid and submerge the entire shrimp shell. Find that there is strong foaming, indicating that a reaction has occurred, and test pH with 1 to 2 is fine. Soak for about 12 hours overnight at room temperature. Stir from time to time to speed up the reaction until no foam is seen. Gas is released. pH test is still acidic. After 12 hours, remove the shrimp shell and rinse with normal water to pH by 7. Then wash with distilled water. At this time, the shrimp shell is lightweight and soft because all inorganic impurities have been removed. Step 2. The collected shrimp shells were drained. Then put into a 500 milliliters flask and at the same time added 3% sodium hydroxide until completely submerged shrimp shells and tested pH with from 11 to 12 as satisfactory. Heat at 90 to 95 degrees Celsius for about 4 hours. After the reaction finished, the products were washed with normal water to pH with 7, then rinsed with distilled water. The obtained product has a pinkish white color. Step 3. The pigment, astaxanthin, present in chitin is removed by the following method. Immerse chitin with 60 milliliters of 1% hydrogen peroxide overnight at room temperature. The product after soaking, although the color has decreased a lot, still sees a slight bend. Washed with water and rinsed with distilled water. Dry the product at 600 degrees Celsius. Obtain clean white chitin. The synthesis efficiency of chitin synthesis was calculated according to the following formula. Synthesis efficiency equals the quotient of the total grams of chitin obtained divided by the total grams of the original shrimp shell multiplied by 100%. In our research, we let chitin dry and weighed 9.42 grams. So, the percentage of chitin in shrimp shell is the quotient of 9.42 divided by 30 multiplied by 100 equals 31.4%. B. Synthesis of glucosamine hydrochloride from chitin. Weighed 4 grams of dry chitin, shredded into a 250 milliliters flask. Then add 32 milliliters of 36% hydrochloric acid. Heat in a water bath and maintain at a temperature of about 90 to 95 degrees Celsius. When the mixture temperature in the reaction vessel reaches of 65 to 70 degrees Celsius, chitin begins to dissolve very quickly to form a dark brown solution. Boil for 4 hours. At the end of the reaction time, the product is filtered hot to remove dirt. Then, the filtrate is decolorized with 1 gram of activated carbon. At this stage, the mixture is heated to 90 degrees Celsius, then maintained at a temperature of 50 to 60 degrees Celsius for 30 minutes. Filter out activated carbon to obtain a transparent pale green solution, and cool to obtain a straw yellow solution. The solution is cooled down at a temperature of 0 to 4 degrees Celsius. The time to crystallize is 12 hours overnight. Crystals of glucosamine hydrochloride was separated by filtration and then washed with alcohol of 96 degrees. The product is dried at 60 degrees Celsius to obtain dry white glucosamine hydrochloride crystals. The synthesis efficiency of glucosamine hydrochloride synthesis from chitin was calculated according to the following formula. The synthesis efficiency equals the sum of the total mass of glucosamine hydrochloride at first crystallization plus the total mass of glucosamine hydrochloride crystallized for the second time, multiplied by 100 and then divided by the total original mass of chitin. C. Glucosamine hydrochloride purification. Weigh 2 grams of glucosamine hydrochloride into a 100 milliliter flask. Gradually add 25 milliliters of 96-degree alcohol and bring to a boil. After the mixture boils, slowly add distilled water until glucosamine hydrochloride is completely dissolved, still maintained at boiling temperature. The amount of distilled water added is 5.5 to 6 milliliters. Heat for another 60 minutes. Filter hot to recrystallize at 0 to 4 degrees Celsius for 4 hours. Crystals were filtered and washed with 96-degree alcohol 2 times 3 milliliters each, dried at 60 degrees Celsius to obtain pure glucosamine hydrochloride. The filtrate was evaporated and recrystallized to further obtain glucosamine hydrochloride. The obtained glucosamine hydrochloride crystals have a beautiful white color with a melting point of 192 to 194 degrees Celsius.